It's about 10 times bigger at the very least relative to the previous interstellar object, and maybe even 50 times bigger than the first interstellar object. And that means that it's somewhere between 1,000 to 100,000 times more massive than the other two interstellar objects that we've seen before. Now, how do we know that? It's basically, we see how much material is evaporating from the surface of the object in the direction of the sun. And that tells us how much push the object could get from that evaporation. But we don't notice, based on all the data that was collected between the 15th of May and the 23rd of September, there is no indication that the object is being pushed away from the sun. And based on all the data that was collected in about 4,000 observations from 227 observatories around the world, we were able, in a new paper, to set a limit on the mass of the object. It has to be very massive so that this evaporation is not pushing it much. We get a mass of 33 billion tons. That's the minimum mass. The object needs to be more massive than that, 33 billion tons, so that it will not be pushed back by the level of evaporation that was measured for it. And that means if you translate that for solid density, you end up with a size that must be larger than 5 kilometers. Now, this is just a lower limit. It could be much larger than that. It could be larger than Manhattan Island. 5 kilometers is about half the size of Manhattan Island. So we don't know how big it actually is, but we have a lower limit, a minimum mass, a minimum size that it could have, and that one is already, 100,000 times bigger in mass than the first interstellar object. Now, why is that puzzling? Well, there is a limited reservoir of material available in interstellar space, and we should have seen 100,000 objects like the first one, Oumuamua. That was the first interstellar object. It was given the name Oumuamua because it was discovered by a telescope in Hawaii, and that means a scout in the Hawaiian language. So there should have been 100,000 of those small ones of the order of the size of a football field, about a tenth of a kilometer in size, for every big one that is the minimum size that we infer for the new interstellar object, 3I Atlas. And we haven't seen 100,000 small ones. In fact, we saw only one or maybe two, and that raises a big question of how come we are seeing such a rare giant object as the third object from interstellar space. And it also looks anomalous in other ways. Its path is in the plane. It's very well aligned with the plane of the planets around the sun. And it has also unusual materials being shed off it, like nickel without iron, that we only find in industrial production of nickel alloys. And so all of this raises the question of whether it might be alien technology. Maybe, the path that it took was designed, it was fine-tuned to come close to planets. That's why it's in the same plane. And the size is much bigger than we expect for a rock, because this is not a rock. And so all of this is really intriguing, and the fun thing of doing science, the fun of discovering more and more evidence about the object is that we can let the data educate us. We don't need to know the answer in advance. And as I often say, the best way to tell the difference between a curious scientist and a dogmatist is to flood them with data. The dogmatist will be worried that the data will violate past beliefs. And the curious scientist, the genuine scientist, will be delighted to learn something new.